We're going to quickly look at subnet masks and how they're used to determine whether or not data needs to be routed onto a different network, or can it be sent directly to a computer within the same network. So if you've gone into your computer's network interface card settings, you'll find that you can change the IP address. You can also change the subnet mask in there. And if we look at the table below, I've got examples of both. So an IP address, really common one in a home network, would be 192.168.0.10. And a subnet mask could look something like 255.255.255.0. Now, what we do with these is we can combine them together to create something called a network ID. We can also derive the host ID from this result as well, but we're really interested in network IDs at this point. The way we get that is by applying a logical bitwise AND operation to the IP and the subnet mask. So essentially we go through and we AND the sort of corresponding pairs of bits, if you like. So we go through, and that would end up at being 192.168.0.1, okay, in this situation at least. And that gives us a network ID. Now what we can then do, as we see in this demo, this sort of illustration of it, is we can compare that to the network IDs of receivers. So if we look at the first one, receiver A in the sort of top right, if we apply the same principle, so we take the the receiver's IP address rather, and the subnet mask, and we do that same operation to produce a network ID, we can see that it's the same as the network ID that we've calculated for the sender. So we therefore know that that is on the same network and therefore does not need to be routed. If we compare that to network B, or receiver B rather, the subnet mask is the same. We've applied that to the IP address, but the network ID that comes out is different. So when we compare it to the network ID of the sender, we know that it's not on the same network, and therefore it must require routing to get to its destination.